All right, guys, today we're going to talk about factoring out the GCF. All right, and GCF stands for our greatest common factor. So when we're doing these problems, we're looking for our greatest common factor. And there's a couple of different ways that you can do it, but the way that we like to do it is to start by looking at just our numbers, or our coefficients, okay? So when we look at just our numbers, we want to choose the smallest one to look at. So we're going to look at 12 here on problem number 1. And my factors of 12 are 1 and 12, 2 and 6, 3 and 4. So then what I want to do is I want to look at each of those factors and see which ones will go evenly, divide evenly into 18. So we see that 2 will go into 18. 6 will go into 18. 3 will go into 18. However, we want to choose the greatest. So we're going to choose 6. And we're going to write up here our GCF. We know that 6 will be part of it. The next thing we want to look at is our variable. So we have a K in one of our terms, but we don't have it in each term. So it's not going to be a common factor because we don't have it in both. So our GCF for this problem is just going to be 6. So we have 12K minus 18. And we want to divide everything in our problem by our GCF. Put the GCF out front. And then whatever our simplification is what goes in these parentheses. So 12 divided by 6, we know is going to give us a 2K. And negative 18 divided by 6 is going to give us a negative 3. So there we have our answer. And remember on these, we're not solving for anything. We're just changing the form of our original problem, just factoring something out. And we want to make sure once we get to the end that whatever's within these parentheses doesn't have any common factors, right? So 2 and 3 shouldn't have any common factors because we want it to be in simplest form. And those also should be whole numbers. We don't want any fractions, okay? We want it simplest form. So now on number 2, we're going to start by looking at our smallest number, our smallest coefficient, which is 40. Our factors of 40 are going to be 1 and 40, 2 and 20. 3 doesn't go in evenly. 4 and 10, and 5 and 8. All right, now we want to choose the biggest of those factors that will divide evenly into 64. For this problem, that's going to be 8. So part of our GCF is going to be 8. However, we also need to look at our variables on this problem. So for this problem, we have x to the 8th or x to the 4th. So now we have to decide which variable and what power will go into everything, okay? So if I have 8 x's here, can I take 4 x's away? I can. If I have 4 x's here, I can take 4 x's away. Now some of you may want to say that x to the 8th is our greatest common factor because it's the greatest. However, if we look here at x to the 4th, x to the 4th cannot give away 8 x's. It's too many. So for our variables, a good rule of thumb is that if the variable is present in each term, pick the smallest power. Okay? So in this case, we're going to pick 8x to the 4th because x to the 8th can give away 4 x's. Okay? X to the 4th can give away 4 x's. The next thing we're going to look at is our y's. We'll see that we just have one y present in both terms. So that one y is a common factor. Okay? So then, just like the last one, we'll rewrite our problem. 40x to the 8 times y plus 64x to the 4th times y. Okay? And we want to divide everything by our GCF. So divide by 8x to the 4th y here, and divide by 8x to the 4th y here. And remember, when we write our answer, we want to write our 8x to the 4th y out front, and then our simplification within those parentheses. So the first thing I like to look at is just my coefficients. So in this first one, I'm just looking at 40 divided by 8. And 40 divided by 8, we know, is just going to give us a 5. Now, the next thing I have to look at is where it gets a little tricky. Now I want to look at my x's. So we have x to the 8 divided by x to the 4th. So let's come down here so that we can think about that a little bit. X to the 8 divided by x to the 4th. So one thing that we could do to figure out kind of what this means is just write this out, expand it. So we've got 2, 3, 4, 5, 6, 7, 8. Right? X times itself 8 times. Over x to the 4th is x times itself 4 times. Okay? And so from that, we know that we can cancel, 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 cancel. And we're left with 4 x's or x to the 4th. However, I don't know about y'all, but I don't want to do that every time. And I definitely don't want to do that if I have x to the 36 or something like that. So, I would rather use a shortcut. Notice that the x's in the bottom, my 4 x's, are being taken away from my x's in the top. So we're taking 4 x's away from x to the 8. Whenever we're taking something away, that lines up with subtraction. Okay? So a good thing to remember from your exponent rules is that whenever you are dividing powers, dividing exponents, you can subtract your exponents. Okay? So since I have x to the 8 in the top, and I'm taking 4 away from the bottom, I will end up with x to the 4th, which is what we got when we expanded it all the way out, but a lot quicker and easier, especially if we have a large exponent. So, coming back up here, now that we know x to the 8 divided by x to the 4th is going to give us x to the 4th, and y divided by y is actually just going to cancel out, right? Because imagine if you have 5 divided by 5. That just gives you 1, cancels out. Anything divided by itself is just going to give you 1, cancel out. Okay? Next up, we've got our 64 divided by 8. It's going to give us an 8. This time we have x to the 4th divided by 4. So just like we did with our y, anything divided by itself is going to cancel out. And again with our y. So, stopping right here is our answer for that problem. On this next page, I would like for you guys to try number 3 by yourself. So stop, pause the video here, and give number 3 a try. So for number 3, you should have looked at our smallest whole number, 7, and seen that our GCF is going to have a 7. You also would have seen that this m squared can be taken away from each term, because 6 can give up 2, m to the 6th can give up 2m, m to the 3rd can give up 2m. So our GCF there is going to be 7m squared. Okay? So then, we're just going to divide each by our GCF. Okay? We're going to put our GCF out front so we don't forget it. And then we're going to simplify. 14 divided by 7 will give us a 2. M to the 6 divided by m squared. Remember we said that that will subtract because we are taking 2 away from the m to the 6. So that's going to give us an m to the 4th. Negative 35 divided by 7 is going to give us a negative 5. Our m to the 3rd divided by m squared, right here, will give us an m to the 3rd power minus 2, because we are taking 2 away from the top, which will just be an m to the 1st power, or we can just write m. Now this last piece, negative 7m squared divided by 7m squared. Remember, we just talked about the fact that anything divided by itself equals 1. So we have 7m squared divided by 7m squared. That's just going to become a 1, because anything divided by itself equals 1. And a lot of people would want to just leave this off. But that is still a part of our problem. That 1 still needs to be there, because we don't want to lose that whole term. It's not a 0, it's a 1. So remember, we have our subtraction right here. So it's going to become a minus 1. Okay? There's your answer for that one. I want y'all to pause the video here and give number 4 a try. All right, so for number 4, we start by looking at our smallest number, our smallest coefficient, 3. We look at 3 and we think to ourselves, does 3 divide evenly into 5? No, it does not. Does 3 divide evenly into 8? No, it does not. Even if 3 had divided into one of these, it still would not be a common factor, because we need it to divide evenly into all of them. Okay? So our 3 is not going to be a part of our GCF. Next, we start looking at our variables. So the first thing we're going to look at is our A. We think to ourselves, is there an A in each term? There is. One term has 2 A's, and the other just have 1 A. So that means that this first term only has 1 A that it can give up. Okay? So that's going to be just an A. It's going to be part of our greatest common factor, right? Because if we were to choose A squared, well, then this first term doesn't have 2 A's that it can give up. Okay? Same thing with our B's. We see a B in every term. Now we have to decide how many B's are in every term. Well, this term only has 1 B that it can give up. So even though this term could give up 2 B's, the rest cannot. So our greatest common factor, the greatest one that every term has, is just 1 B. Okay? So we have our GCF of AB that we're dividing each piece by. Okay? We put our GCF out front so we don't forget it. 3 just stays a 3 because there's nothing to divide it by. Our A will cancel out. And then we have B squared divided by B. So for our B squared divided by B, we can think to ourselves, B times B, that's the same as B squared divided by B, and cancel out. Or, since that's more work than we like to do, we would say we have 2 B's in the top minus our 1 B in the bottom, because all the bottom has to give us is 1, equals just a B. Okay? So here we have just 3B. Using that same reasoning, we have a minus 5 we see that our b's will cancel out, and we have an a squared divided by a, which becomes a to the second power in the top minus the 1 in the bottom gives us just an a. So then we have just a 5a here. And then with our 8, we have a plus 8. And our a's cancel out and our b's cancel out. So it's just plus 8 for that last term.
Okay, so let's look at the next slide. So we're going to factor trinomials when your a, which is, remember your trinomials go in the form of ax squared plus bx plus c. So we're going to look at when the coefficient for the squared term is just 1. Now, oftentimes with these you can do them in your head, but we are requiring that you show work so that when we do put a number in front of the squared term that's not 1, like a 3x squared, that you know how to factor it. So here we go. So when factoring, always look for greatest common factor. So you learn how to take out the greatest common factor. So we always look for that first. So as you're looking through these 4 problems here, 5 through 6, you want to look at all the coefficients and all the variables to make sure that to determine, do they have anything in common? And if you look at all 4 of these, none of them have a constant in common or a variable in common. So we don't have to factor out that GCF first. We will do some where you have to do that, but not right now. So then the method that we're going to use, you're basically going to read backwards this problem. So as you look at this problem, we're going to read it backwards. So in other words, we're going to take that 45 and we are going to add, because there's a plus here, we're going to take the factors of 45 and add them to get 14. All right, so we're going to do that in a table. So again, reading backwards, we're going to start here, and so you might want to write this on your notes. You're going to find the factors of 45 that in this case, because there's a plus in front of the 45, you're going to add. If there had been a negative in front of that 45, we would be subtracting the factors of 45. So you're going to find the factors of 45 that add to give the middle term, and in this case, the middle term is a positive 14. Okay? So in your chart, you're going to take that 45 and you're going to put it here. Then above the 45, you're going to write plus or minus to determine whether you're adding or subtracting. Because there's a plus in front of that 45, you're going to put a plus up here. That tells you you're adding those factors of 45. Then we are looking for our middle term, which is a positive 14. I really could care less right now about the sign of that middle term. I'm really concerned about the factors of 45 and whether I'm adding or subtracting. So you're going to find all the factors of 45. So starting with 1 and 45. If I add those together, I get 46. That's not what I'm looking for, not 14, so keep going. The next number after 1 is 2. 2 does not divide into 45. Next number is 3. 3 goes into 45 15 times. If you add those together, you get 18. Still not what we're looking for. The next number after 3 is 4. 4 does not divide in there. Next number is 5. 5 goes into 45 9 times. And then if you add those together, you get 14. And that's what we're looking for. So we found the 2 factors of 45 that add to give us 14. Now pay attention to the sign. Your 14 is positive. We know that because we put that in our chart and it came from our problem. 100% of the time, out of these 2 factors, the biggest one, the largest one, is going to carry the same sign as your middle term. So because 9 is bigger, it's going to carry that plus sign. So then all you have to figure out is what is the sign of the smaller one. So if the 5 is negative, it would actually reduce the 9 and make it a 4 instead of a 14. So we need the 5 to be a positive so that it adds the 9 to make it 14. And so once you have the factors of the signs, then all that's left is for you to write out your binomials. So the x squared becomes x and x. And then straight from your chart, you have a plus 5 and a plus 9. So put the plus 5 here and the plus 9 here. And then this becomes your final answer. You can re-multiply to check and make sure that you have the correct signs and the correct numbers. So in your head, you would be going x times x is x squared, so check that one. And then x times 9 would be 9x, and so that's one of your middle terms. Then 5 times x is 5x, so that 9x and 5x adds to give you the 14x, so there's a check. And then finally, 5 times 9 is 45, and so there's a check. So I know by remultiplying that I must have factored correctly. So why don't you stop the video and try number 6 on your own. If you still are struggling with a method, you can watch me do it again. So if you're ready, pause. If not, keep listening. All right, so for this one, we're going to read backwards, right? So you're going to read backwards this way. What factors of 26? So in your chart, you're going to write a 26. Because there is a plus in front of that 26, we're going to add the factors of 26. And we are looking for our middle term right there of negative 15. So I'm going to take my factors of 26, so start with 1 and 26. We are adding, so we get 27. Not what we're looking for. Next number after 1 is 2. 2 divides into 26 13 times. Add those together, you get 15, and there it is. So you found it right away. Now look at your signs. The sign of your 15, your middle term, is negative. As I said before, 100% of the time, the bigger of the two numbers will carry that same sign. So all you have to do is figure out the sign of the 2. Is it positive or negative? For 2 to combine with negative 13, in this case, it has to be negative. And now you've done all your work, and you just have to write out your binomials. So the w squared becomes w and w, and then you have a minus 2 and a minus 13 from your table. And of course, you could refoil, remultiply to check your answer. All right, so let's look at what happens when our constant is negative. So again, we're still reading it backwards, but we're reading it backwards this time. We're going to take the factors of 48. And because there is a negative sign in front of the 48, we are going to subtract our factors of 48. And we are looking for this middle term right here of a positive 2. So we'll start with our factors of 48, 1 and 48. Remember, we're subtracting, so 48 minus 1 is 47. Not what we're looking for. Next number after 1 is 2. 2 goes into 48 24 times. If you subtract them, you get 22. Still not what we're looking for. Next number after 2 is 3. 3 divides into 48 16 times. And then if you add those, you get 19. We're getting closer to 2. We're going in the right direction. 4 divides into 48 12 times. So if you subtract those, you get an 8. Much closer. Next number is 5. It does not divide into 48. Next number is 6. It divides in there because 2 and 3 did. So 6 goes into 48. 6 times 8 is 48. And lo and behold, there is the number that we're looking for. So now all that's left is for you to determine the signs. We know that the sign of our 2 is positive because that's what it says in the original problem. 100% of the time, the bigger of the two numbers gets that same sign. And in order for the 6 to combine with the 8 to make a 2, the 6 is going to have to be negative. So now you're ready to throw those into your binomials. C squared becomes C and C, and then minus 6, and C minus C8. Remultiply the check, and your answers are correct. So now I definitely want you to pause the video at this point, and I want you to try 8 on your own. So you're going to determine whether you're adding or subtracting the factors of 72, and what is the coefficient of that middle term, because I don't see it. So that coefficient I'm subtracting in n. How many n's am I subtracting? Just 1. So pause the video and factor. Okay, so you should have taken and read this backwards. You're going to take the factors of 72. Because there is a negative in front of the 72, we are subtracting the factors of 72. And we are looking for that middle term of -1. So 1 and 72, they subtract and give you 71. 2 and 36 subtracts to give you 34. 3 and 24 subtracts to give you 21. 4 actually goes into 72. So 4 goes in there 18 times, and it subtracts to give you 14. 5 does not go into 72. 6 does because 2 and 3 did. So 6 goes in there 12 times. Subtracting gives us 6. 7 does not go into 72. 8 goes into 72 9 times. And when you subtract, you get 1, and that's the one that we're looking for. Now, if you had known, as you read backwards here, that the factors of 72 that subtract to give you 1 are 8 and 9, you jump directly to this in your chart, so long as you just draw that T-chart. You could have just had what I circled in red in that T-chart, and that's fine. You don't have to go through the whole thing if you know it immediately. So this is the minimal amount of work that we require. The sign of our 1 is negative. The bigger the 2 carries that sign. So all you have to figure out is the sign of the 8. So the 8 is going to have to be positive for it to combine with 9, -9, to make a -1. So then write your binomials. You get n plus 8 and n minus 9. Now it's beneficial if we talk about the fact that it doesn't matter what order your binomials go in. You could have written your binomials as n minus 9 times n plus 8. It doesn't matter what order the binomials go in, so long as you have the correct signs in front of the correct numbers. All right, next slide, we're almost done. So in example B, I want you to go ahead and pause the video and do number 9 and number 10 on your own. So at this point, you should be feeling a lot more comfortable. So pause the video. All right, so reading backwards, the factors of 36, and so I'm going to start to shorten up my chart a little bit to show you the kind of work that you could do if you came up with your factors immediately. So the factors of 36, because there's a plus in front of 36, we're going to add to find positive 12. So if you know what the factors of 36 are right away, that add to give you 12, you can just throw that in the table. And that would be 6 times 6 is 36, 6 plus 6 is 12. If you couldn't come up with that right away, then you have to start going through all those factors. 1 and 36, 2 and 18, 3 and 12, 4 and 9, and so forth. All right, so now that we found our 12 is positive. The bigger the 2 carries the sign, well, they're both the same. So that's kind of a clue that they're both going to carry that same sign. And so your binomials are going to be A plus 6, A plus 6. Now that's a binomial squared. So you could have just written, because it's the same thing times the same thing, A plus 6 squared. Either one of those is correct. All right, now number 10 kind of throws some students once in a while because they look at number 10 and they think to themselves, read it backwards, what factors of 1 add to give you 2? There's no factors of 1 that add to give you 2. Well, there are. So let's consider 1. There's a plus in front of that 1, so we're going to add the factors of 1, and we're looking for that -2. There's only one set of factors for 1, and it's 1 and 1. So they either add to give you 2 or subtract to give you 0. So it's important to know whether you're adding or subtracting. So in this case, we are adding, so we get 2, which is exactly what we want. We want our 2 to be negative. The bigger the 2 carries the sign, since they're both the same, they both get the same sign. And so your binomial is going to look like n minus 1 times n minus 1. So again, just like example 9, you can write that as n minus 1 squared. Now, 11 and 12 are different than all the rest of them by what? What do you see that's not like the others? Isn't there a coefficient in front of the squared term on both of these? So we were factoring trinomials where a, because that's your a value, 2 and 5 in these cases, is 1. We haven't talked about if a isn't 1. So go back to the next slide. Remember, your very first question should always be, is there a GCF? Well, as you look at number 11, look at these three numbers. The smallest is 2. Does 2 divide into 16 and 40? Yes. So there is a GCF of at least 2 on number 11. Then look at your variables. Does every term have a k? The negative 40 is missing a k, so they don't have a k in common. So instead, we're going to factor out that 2. It will not disappear. It will go in front of our total factoring. So when you divide everything by the GCF of 2, you're going to bring that out in front and then do your division. So here the 2's are going to cancel and you get k squared. Then negative 16 divided by 2 is negative 8. Bring down that k. Negative 40 divided by negative 2 is negative 20. And now you get to factor the trinomial that's inside. So this trinomial here, right here, needs to be factored. So right now, the coefficient in front of here is now a 1. So now we can use that method that we were looking at before. So let's go ahead and read this backwards. So if I read it backwards, we're going to take the factors of 20. Because there's a negative in front of that 20, we're going to subtract the factors of 20. And we're looking for a middle term of negative 8. If you know immediately that the factors of 20 that subtract, because there's a negative in front of the 20, so they subtract, give you 8. Well, that's not 4 and 5 because that's 1. It is 2 and 10. 2 times 10 gives you 20. And then 10 minus 2 is 8. So you can shorten up your chart by doing that. Again, you couldn't come up with that in your head. You're going to do 1 and 20, 2 and 10. Oh, there it is. All right, so always go back to doing one of the numbers. So your 8 is negative. The bigger of the 2 is going to carry that sign. So the 10 gets the negative. The 2 is going to have to be a positive in order to bring that negative 10 down to a negative 8. So then you're going to rewrite. So we've got a 2 out in front, and here's our 2 binomials. Don't forget about that 2. And then that trinomial inside becomes a k plus 2 on your chart, and a k minus 10. And then your entire answer is all of this right here. So now you try number 12 on your own. Pause the video. You know there's a GCF, right? So find the GCF. What is the number? Are there variables in the GCF? Divide it out, and then take the resulting trinomial and factor that. Pause the video. Okay, so you should have discovered that the GCF was equal to 5. There are no variables that they have in common because the 30 does not have a z attached to it. So we're going to divide each of these by just a 5. And you're going to pull that 5 out in front and do your division. So these 5s are going to cancel, and you get z squared. Negative 25 divided by 5 is negative 5, and then don't forget about your z. 30 divided by 5 is positive 6. So now reading backwards from here to here, you're going to take the factors of 6. Because there's a plus in front of 6, we're going to add those factors of 6, and we're looking for negative 5. So you have to be careful, especially when you're dealing with 5 and 6 in this chart. There are factors of 6 that add to give you 5, and there are factors of 6 that subtract to give you 5. So it is important that you know whether you're adding or subtracting. For instance, the factors of 6 are 1 and 6, and 2 and 5. Or sorry, 2 and 3. So as you can see, if you take the 1 and 6 and subtract them, you get 5. If you take the 2 and 3 and add them, you get 5. So it's important to note that we are indeed adding. So 1 plus 6 is 7. 2 plus 3 is 5, so what I want is the 2 and the 3, not the 1 and the 6, so don't fall in that trap. My 5 has a sign that's negative, so the bigger of the 2, which is 3, gets that negative. So for the negative 2, or for the 2 that combine with the negative 3, it is going to have to be negative as well. So then your final factoring is going to be 5 times z minus 2, z minus 3. So final answer. And you did it. Good job.